looking at this slide, I'm sorry, I'm just trying to center this a little bit. Excuse me for a moment. What we have is a very robust geographic pattern. The most obvious one, if you look at insolation, which is watts per square meter. So, kind of a typical desk that you might work on, maybe is about a square meter in size. And what we're looking at is the amount of power on a sustained basis on average received by different parts of the Earth's surface. And the first obvious pattern that's really consistent is that anywhere in the higher latitudes, there's not very much insulation received in the blue colors there. Why is that? Okay, so quick review. You might recall that everywhere on the planet, half of a whole year is day and half is night. So it isn't day length, it is intensity of solar radiation received by the ground, which is driven by solar altitude, how high the sun is in the sky, plain and simple. And that's also why the temperatures are so different in the tropical areas versus the poles, too. So, no surprises there. You say, wow, Dr. McGlade's geography class, it's amazing. He tells us where there's lots of sun, it's warmer. How profound. So, okay. But that is really important to look at that pattern there. So, very much a polar low, very low levels there. So, what's the other pattern? Where is a lot? So, if you look at the numbers that are orange and even almost red, those are the big numbers. And look at, wow, Northern Africa, the Middle East, and then in a stretch across the Southern Hemisphere, right about the tropic line, and a little bit outside the tropics too, is the Australia, South Africa, and a little bit there in the Amazonian basin, just outside the basin, actually. And of course, the United States and Northwest Mexico. So those are all big numbers there. And here's the amazing thing. There was a study done almost 2 decades ago now. The Grand Solar Plan, if you've had my 106 class, you probably know about that. It showed that we could power all of the electricity needs of the whole country in terms of just total power with the sunlight in the Southwest. And in fact, just a corner of Nevada would do the trick. It's an enormous resource. It's way more than we need. Of course, the trick would be to store it at night and so on. But we do have ways of storing electricity. That's for another day, though, discussion. But so we have enough sun in the United States to do the trick. Actually, that map is not really very good. There's a lot more interior. If you go west side, east side of the mountains here in the west, you get a lot more numbers and on the east side there. So that's a very, very generalized map, unfortunately. But still, the broad patterns are clear. And for the sake of looking at Europe, big plans already. Northern Africa, they're putting big solar installations, and I think Algeria is the biggest installer, and Morocco are the two. Another interesting one, the oil-rich Middle East, countries like, well, Saudi Arabia, United Arab Emirates, for example. About 7 years ago now, they started making these announcements and offers for tender to put in solar farms to produce electricity. Up to that point, they had been using their own oil, refined the diesel fuel out of it, and they had these giant diesel generators, and they were making their electricity that way for the most part. And now they're just using the sun. Why are they doing that when they have so much oil? Because it's cheaper. This will probably be remembered as the solar century. We have so much solar radiation, and the panels are now so cheap that literally, even in oil-rich countries, it's cheaper to generate their solar electricity with the panels, store some of the energy at night. Some of the plants are doing that. Or maybe use a backup generator at night if you need to. Air conditioning in those big cities, that's what they're doing. So lots of solar energy in the world, but even modest solar energy like we have in Oregon, especially say other side of the Cascades, has great potential. So a little more on this. I just realized, well, sorry about that little cut there. I realized I wanted to say a couple other things. One is equatorial areas. Not so much solar radiation. Look around the equator. There's not a single orange color anywhere. Those are areas of persistent cloudiness. There's an intertropical convergence zone that we'll learn about later there. So those are very, very cloudy areas. That's why not so much sun in those areas. Just wanted to point that out now a little bit. We'll later learn the dynamics that cause that.